Okay, this is your review for your third assessment over the composite functions. Remember these? Okay. F of x equals 4x minus 2. G of x is 3x to the power of 2 plus 4. Now the first thing I'm supposed to do is find a simplified expression for f plus g of x. So make two parentheses. Oh yeah, there's a plus sign between them. So 4x minus 2, 3x squared plus 4. Okay. All right, so parentheses I can't add or subtract within them. Exponents just belongs to the x. Multiplication, no. Division, no. So adding like terms. So highest power is a 2, and then x, then nothing. So 3 goes here, 4 goes here, and then negative 2 plus 4 is 2. Okay, now what we do is we put 3 in for x in a parentheses, because I know what x is. Now I got to find if x was 3, what would we have? Okay, I would have 41. Okay, now we're minusing. Same procedure, just one little change you have to make. So f minus g. F is 4x minus 2, and g is 3x squared plus 4. Okay, now make your plus and switch both of these to the opposite, and then I've got x to the second, x, and this. So x to the second is negative 3. X would have the 4. And I take negative 2 plus negative 4, that's negative 6. And then I plug negative 4 in for x. Negative 62 is what I got. I might have did that wrong. If I did, well. Okay. Divided by, okay, so f, 4x minus 2, divided by g, 2x squared, 3x squared plus 4. I'm going to circle that. Now I insert the 2 in. So if I insert 2 in the top, 4 times 2 is 8, minus 2 is 6. Okay. Now on bottom, 3 times 2 to the second power plus 4. I'm going to bet you that's 16. Okay, and we can reduce those to 3/8. Okay, I would like that reduced if you can find something that can reduce it by. Now we come to the dreaded inputs. Again, that should be an empty circle. You can't see it. It should be empty. Because otherwise you'd think, oh, it's times, and it would be, but it's not. Okay, so input. I start with my f function, which is 4 times x minus 2. Now, x turns into something else, and it turns into the entire g function, which is 3x to the power of 2 plus 4. Now I go through my order of operations. Okay, so my parentheses, you have them, but you can't add in there. Power just belongs to the x, so I don't have to worry about that. Multiply, yeah, I need to multiply 4 through there. So 12x to the second plus 16 minus 2. Okay, any division? No. Addition, yeah, you can add, you can put those together. So that'd be 14. 12x to the second plus 14. Now you insert 3 in, get your answer. So 12 times 3 to the second plus 14, and that gives me 122. Okay, g. Okay, so g was the 3x to the second plus 4. Now 3 times x, but now we're going to take 3 times something else, and that has a second power plus 4. So 4x minus 2. Okay. Okay, parentheses, you can't subtract those. Exponent, yeah, and it belongs to the whole parentheses, not just the x variable. So what I want to do is write 3, make a new parentheses without the second power, and to find what goes in there, we need to duplicate that out. Stays the same, don't switch it to plus. Second power, it stays identical signs. Then FOIL, 4x times 4x times negative 2. Negative 2 times 4x and times negative 2. So 16x to the second, negative 8x, negative 8x, and 4. So I'm going to have in this parentheses the x to the 16x to the second, negative 16x, and 4. Okay? So now the exponent's still there, but now it's on just the x, like it should be. Okay, multiplication, yep, multiply a 3 to all those, so 48. I have a lot of people that just write this down and plug that in. No, you got other stuff. You had a 3 multiplied and a 4 being added. So 48x to the second minus 48x plus 12 plus 4. So that's 16. Okay, now we can insert negative 10 into our simplified expression. So 48 times negative 10, second power, minus 48, negative 10, plus 16. 5,296. Okay, now these are pretty easy if you know what you're doing. Now they've done the input, and you need to separate it into two separate functions. So 8 times the parentheses x minus 3, all that belongs to the second power, plus 4. Now, since g's second, let's go find the part that's kind of isolated, or not isolated, just confined. So x minus 3 is kind of an expression unto itself. So then I have 8. I have a parentheses. You can put the parentheses. You don't really have to. X, and then to the second power plus 4. So if I were to replace that x, I would replace it with x minus 3, which is what they have done. Okay, finding the inverse. First thing, you need to switch the x and the y. Okay. Now you need to isolate the y. Okay. So I got an 8 that I need to add, and that would be added to x, but I don't have x. It's not 8x, it's multiplied by 8. Okay, I have a 3 as a multiplier, so we undo that by dividing. And then I undo the second power with the square root. So I have y and the square root of x plus 8 over 3. Okay, and that is how you find the inverse. Okay, and now this one has gotten a lot of people in the past. At a store, I have a coupon for $10 off and another coupon for 30% off. Purchase price, which I don't know at this point, X dollars. The store will let me use them both for the same purchase, but I want to know which one to apply first. Now, it kind of takes you through step by step to get where you want to be. Write an equation for $10 off being applied to our unknown price, which is X dollars. Now, X is dollars, 10 is dollars, so I just subtract 10 from whatever X is going to be. And I title that F of X. I would suggest putting a 1 there to help you with the coefficient multiplication. Okay, now this is what gets people. Write an equation for 30% off being applied to the unknown price of X dollars. Now, here's a case point. You got X, but you can't, it's a percent, so you can't just minus it. Okay, you can't put X minus 30, that's wrong. Okay, percents work as multipliers with unknown prices. But I'm not going to use 30%. I got to pretend, okay, I'm paying 100%. Oh, 30% off, that means I'm paying 70%. So 0.70 will be the multiplier of the X, and I title that with G of X. Okay, works totally different. So compose your equations so that $10 off comes first. So to make the composition, we make these two. and I use my input operation. And remember, X is going through the gauntlet here. It needs to pass through here before it gets to here. And the $10 off, X needs to pass through that first. So that's F going here and G here. Now to simplify it, I write the G first. So 0.70x, replace your X. X is out, and now 1x minus 10 goes in. Okay, so now I distribute. So 0.70x minus 7. Okay, compose your equations together so 30% off comes first. Okay, so X goes here first. 30% off was done here, and that ended up being my G and my F. So now I write my F down. 1x minus 10. Now it's good we have the 1 there, so now I know what to multiply by the parentheses by. And I put my G, which was 0.70x. I multiply that, so 0.70x minus 10. Find the cost using each composition with a $400 purchase. So we're going to put $400 in for those x's. Okay, so 0.70 times 400 minus 7 gives me $273. And then that one's going to give you $270. I know that because you're taking off $3 more. Okay? All right. There we go on that one.